So up until this point, we've talked about a number of different measurements. For example, we talked about length, we talked about time, we talked about volume. One we have not touched on is temperature. Okay? So an important thing for you to note, when we take our temperature, we normally just get a number. For example, we get 98.6 and we know that we're not sick. But what exactly is temperature measuring? Well, temperature is actually a measurement of how fast molecules are moving. So the higher your temperature, the faster the molecules are moving. So whether that be molecules in your body, molecules in the water you're trying to boil, that is what temperature is actually measuring. Now, there are two different units of temperature that you're probably very familiar with: Fahrenheit and Celsius. So if we look at some common values, water, and this is important, water boils at 100 degrees Celsius and it freezes at 0 degrees Celsius. If I were to convert that into Fahrenheit, that's 212 degrees Fahrenheit, which is probably a number you're not as familiar with as 100 degrees Celsius for boiling water, and it freezes at 32. That's why when it's 31 degrees outside Fahrenheit, it's really cold because it's below freezing. Okay? So in most parts of the world, people use Celsius. Here in the US, I don't know why, but we use Fahrenheit. All right? So there has to be a way to convert between Fahrenheit and Celsius. And there is. And there's a formula I'm going to give you. And you will always be given this, so you don't have to memorize it. The temperature in Fahrenheit equals 1.8 times the temperature in Celsius plus 32. Okay, so that's an easy conversion and we'll do some practice with that. Now the other unit for temperature that we haven't talked about is Kelvin, and you might not have heard of Kelvin before, and that's fine. It's not commonly used. Kelvin is simply another unit for temperature, and the reason why we use Kelvin, if you notice here, there's this thing called absolute zero. And absolute zero is when all molecule movement stops. So notice how cold it is in Fahrenheit and in Celsius. We will never reach 0 Kelvin. 0 Kelvin is the absolute coldest. There's nothing below Kelvin. So the reason why Kelvin for a unit is valuable is you cannot get a negative value for Kelvin. 0 is the absolute lowest it can go. Now notice water freezes at 273 Kelvin and it boils at 373. So if you notice, for Celsius, it's 0 degrees Celsius that it's freezing, but 273 for Kelvin. For Celsius, it's 100 degrees Celsius when it boils. It's 373 when it boils for Kelvin. So what that tells me is my formula, and I actually round it a little bit, which is fine. My temperature in Kelvin equals my temperature in Celsius plus 273. I'm not going to add the 0.15 that they have. I'm just going to say it's 273. All right, so now let's work on converting between Fahrenheit, Celsius, and Kelvin with 3 examples. Here it says, what is 21 degrees Celsius in Fahrenheit? So I need to use my formula. I know that my temperature in Fahrenheit equals 1.8 times my temperature in Celsius plus 32. Okay, let's plug in the value that I know. I know my temperature of Celsius is 21, so my temperature in Fahrenheit equals 1.8 times 21 plus 32. Okay, so when I plug that into my calculator, the answer I get for Fahrenheit is 69.8. Okay, and my units are degrees Fahrenheit. Now, you might be thinking, and you probably never thought of this before this class, but you might be thinking, okay, how do I round? Well, what you need to keep in mind is whatever mathematical step you took last, that is what you're going to round to. So notice I took 1.8 multiplied by 21, and then I added 32 to that. So my last step is actually addition. So remember, for addition, you round based on the fewest number of decimal places. So for this problem, 1.8 times 21 is 37.8. So that has one, I'll write it right above here for you to see. 37.8, that has 1 decimal place. 32 has no decimal places, which means I want my final answer to have no decimal places. So I'm going to get rid of this 8, and that's actually going to round the 9 up and you're going to have 70. Now, the important thing for you to know here is if I just wrote it as 70, this would be one significant figure, but I'm not wanting one sig fig, I'm just wanting no decimal places. So if I want no decimal places, I'm going to put just a decimal here because then that will give me two significant figures. So I don't want to say it's just one sig fig because I'm certain of the 7 and it's the 0 that I'm estimating. So I'm going to write 70 point, and my units are degrees Fahrenheit. Okay, let's look at the next example. What is 100 degrees Celsius in Kelvin? Okay, so I'm going to use my Kelvin to Celsius, or Celsius to Kelvin formula. Okay. My temperature in Celsius is 100 degrees, so 100 plus 273. Okay. And my answer I get is 373. My units are Kelvin. Notice I don't put degrees Kelvin, it's just Kelvin. One thing to note, notice 100 has no decimal places, 273 has no decimal places, so this is my new answer. So keep in mind, notice 100 degrees Celsius initially had one sig fig. By converting it to Kelvin, you now have 3 significant figures. So that'll matter later on in the year, but just keep that in mind. And that's it. Let's look at the third example. What is 65.3 degrees Fahrenheit in Kelvin? Well, for this problem, I can't go directly from Fahrenheit to Kelvin. I'm going to have to go from Fahrenheit to Celsius, and then, so Fahrenheit to Celsius, and then from Celsius into Kelvin. So let's do that. I'm going to use my Fahrenheit formula. My TF equals 1.8 times TC plus 32. Okay, and so when I plug this in, I know my temperature in Fahrenheit is 65.3 equals 1.8 times TC plus 32. Okay, the math I'm going to do, I'm going to take 65.3, I'm going to subtract 32 from that, and then I'm going to divide by 1.8. And so the answer I get there, once I've done that, is 18.5. Notice I'm not rounding yet because I'm not done. I'm in degrees Celsius right now, but I don't want to stay in Celsius. I want to get into Kelvin. So now I'm going to have to use the Kelvin and Celsius formula. My temperature in Kelvin equals my temperature in Celsius plus 273. So I'm going to take 18.5, which is my temperature in Celsius, and I'm going to add 273 to that. And so the answer that I get there, unrounded, is 291.5. My units are Kelvin. Now keep in mind, because the last step I did was add, I'm going to round based on the fewest number of decimal places. 18.5 has one decimal place, 273 has no decimal places, so I'm going to want to round this guy to give it no decimal places, so it's going to be 292 Kelvin is my temperature. And notice again, no degrees Kelvin, just Kelvin.